So let's begin with a straightforward example. So the first example that I'll give you is the function f of x is equal to 3x minus x cubed. Just as I said, to be able to introduce all the notations. Now, if you differentiate it, you get 3 minus 3x squared. And I can factor that. Right? This is 3 times 1 minus x times 1 plus x. Okay? And so I can decide whether the derivative is positive or negative easily enough. Namely, just staring at this, I can see that when negative 1 is less than x is less than 1, in that range there, both these numbers, both these factors are positive. 1 minus x is a positive number, and 1 plus x is a positive number. So in this range, f prime of x is positive. So f is increasing. And similarly, in the other ranges, if x is very, very large, this becomes, if it crosses 1, in fact, this factor becomes negative, and this one stays positive. So when x is bigger than 1, we have that f prime of x is negative, and so f is decreasing. And the same thing goes for the other side. When it's less than negative 1, that also works this way because when it's less than negative 1, this factor is positive, but the other one is negative. All right? So in both of these cases, we get that it's decreasing. So now, here's the schematic picture of this function. So here's negative 1, here's 1. It's going to go down, up, down. All right? That's what it's doing. All right, maybe I'll just leave it alone like this. All right? That's what it looks like. So this is the kind of information we can get right off the bat. And you notice immediately that it's very important from the features of the function, the sort of key features of the function that we see here, are these two places. All right? Maybe I'll even mark them in like this. And these things are turning points. Okay? Now, so what are they? Well, they're just the points where the derivative changes sign, where it's negative here and it's positive there, so there it must be 0. So we have a definition, and this is the most important definition in this subject, which is that if f prime of x 0 is equal to 0, we call x0 a critical point. Okay, the word turning point is not used just because, in fact, it doesn't have to turn around at those points. But certainly, if it turns around, then this will happen. And we also have another notation, which is the number y0, which is f of x0, is called a critical value. All right? So these are the key numbers that we're going to have to work out in order to understand what the function looks like.